for a review. And then tomorrow and Monday, we're just going to do like mixed reviews with everything. So tomorrow we're going to do a bunch of multiple choice. We're going to look at calculator and non-calculator. And then Monday we'll look at some free responses. And then Tuesday you'll have your test. So what I want to do today is kind of go over quickly what we did yesterday. So as a bell ringer, I have a 5 for 5 on slope fields and differentials. So these are your questions, and then the answers can get turned in on your formative. That way I can see how we are doing and see us as a group. So again, it gives you an idea of what maybe we need to work on tomorrow. Outside and then it was pouring. Yeah. as soon as you're done, you can go out and enter your answers. looks like we're almost all entered on Go Formative. Give you guys like 3 more minutes. Again, the idea is that if there's 5 multiple choice questions, roughly 2 to 3 minutes per question. So we're currently at about the 10-minute mark. Yeah. To Go Formative. Alright, let me see if I can tell you. I'm looking to see if I can let it. Okay, here's what happens if it goes to a guest student. So, like, I don't know if you have to log. Oh, it's paused. Sorry. There you go. So, like, you can use that code if you can't log in with the account you previously created. Your name will just be in there, like, multiple times for me. But that's like a class code to get in if you can't get into our assigned class. Does that help? I can also send a link. I'm going to try sending you a link on Teams. Do you hear that code again? There's the guest code if you need it. Alright, so Austin, Bethany, Brooke, Caitlin, which is Kirsten, Case, Cooper. Alright, so Trevor got in as a guest. And Zach, I just need you in. Oh, Trevor, I got your other results signed in some class. Oh no, wait, never mind. It was just delayed. Like, I think because like I have my screen on share, sometimes it's like delayed moving. So like it had Tim's results where your name was for a second. Koiku, you have 2 logins, so I don't know. Can't get into either. Because your name's on there once, like, with a K, and your name's on there once with a Q. Okay, you got it. Dang. It's being super delayed. So it looks like everybody was able to respond. I hit. Yes? No, quite you. Just yours. Are you in now? There you go. All right. So let's go over the correct answers. Let's talk about this. Let's see how we did overall. So, number 1, our correct answer in number 1 was C. So the correct answer in number 1 was C. So we averaged pretty low on number 1. So let's talk about number 1 and why number 1 is C. So it says, which of the following is the solution to the differential equation dy dx equals 3y squared with initial condition y of 0 equals 3? So you get the y squared with the y, the dx. So your very, very first line should have looked like 1 over y squared dy equals 3 dx. And then at that point you take your antiderivative. So 1 over y squared is really like y to the negative 2. So y to the negative 2 says you can add 1, which gives you negative 1, and divide by your new exponent. And then add an x to the dx's, and we can't forget our plus c. So we get y to the negative 1 over negative 1, so that's like negative 1 over y equals 3x plus c. So then we plug in 0 for x, so that part zeroes out. Plug in 3 for y, then we get c equals negative 1/3. So we have negative 1 over y equals 3x minus 1/3. So we got to get y up top, which means I have to flip everything. So I get y equals negative 1 over 3x minus 1/3. And you know and I know that we can't have fractions in fractions, so you have to get a common denominator. Now, if you didn't want to get a common denominator here, way back up here, you could have actually multiplied everything by 3. But ultimately, that would get you to C because this 3 would become a 3, etc., etc. So way back up here, you could have multiplied both sides by 3. And then flipped it. And again, you could factor out a negative, and ultimately still end up with C. Okay, number 2. Correct answer in number 2 was D. We did really good with that one. Correct answer was D. At about an 80% average. Number 3, correct answer was A. Also very good. 5, not so great. Averaged around 40%. So number 4 was D. Well, let's go talk about number 4. So it says, which of the following is the solution to the differential equation with that initial condition? So this one, you have to be a little bit trickier because you have x and y both in your variable. So now, in order to work this problem, you have to get your dy dx's separated knowing the laws of exponents. Okay? So you have dy dx equals e to the x minus y to the 0 equals natural log of 3. Well, if you think about a variable with subtraction, that's the same as that variable written as division. Okay? So remember, if you have the same base, then you can subtract the exponents. Vice versa, if you have subtraction, you can write it as division. Now that allows me to cross multiply. And integrate. The antiderivative of e to the y or e to the x or e to the u is e to the y, e to the x, e to the u. So we get e to the y, e to the x plus c. And then to get y down, you can either plug in your points now and solve for c, or you can ln both sides. I'm going to plug in. So x is 0. And e to the ln of 3. So the e's and the ln's cancel. E to the 0 is 1. So c is 2. So now I have y equals the natural log of e to the x plus 2. Remember that ln and e sort of cancel. However, in this case, it doesn't really help us, and that answer's already on my page as letter D. Okay, and then 5's correct answer was B. 5's correct answer was B. So again, overall, we did pretty well with that, with about 70% of us getting B. Are there any of those that I didn't go over that maybe you wanted to see? Okay. So that is Unit 6. Unit 6 was slope fields and differentials. So that's where you separate your variables. You have general and particulars. And then you kind of work through your problems. So the next part of today, I said, again, we're going to focus on areas. So we're going to start with the area and Riemann sums, and then we're going to move to areas such as volume. Alright, so what I want to do is just go through all the different types of multiple choice questions that you could potentially see that are with area and volume. So again, I feel like the more you see the multiple choice, the easier the multiple choice begin to get, because you're starting to get an understanding of exactly, kind of what they are expecting from you. Okay, so let's look at example number 1. This is a probably difficulty level 4 or 5. So it says, let the function given by f of x equals 4 to the x if 4 subintervals of equal length are used. What is the value of the left Riemann sum for the given function? So we are looking for the Riemann sum for 4 to the x. My upper and lower bounds are 1 and 3. So that means my interval length is 1 to 3. I want 4 subintervals, so that's my n. So my delta x is equal to b minus a over n, or 1/2. So what that means is that each width of this rectangle is 1/2. And then I need to know the heights. So this is a left Riemann sum. So I need to know the heights at all of the left points or endpoints for that sum. So we're going to skip 4 to the 1. Or sorry, we're going to start with 4 to the 1. We're going to skip 4 to the 3 because this is on the left. If you're moving a half interval from 1, then that's like 1 plus 1/2, or 3/2. Then you're moving another half interval away, so 3/2 plus 1/2 is 4/2, but 4/2 is 2. And then add a half to that, so that's 2.5, or 5/2. So 4 to the 1 is 4. 4 to the 3/2, be smart about it. Take your square root first. So the square root of 4 is 2. 2 cubed is 8. 4 squared is 16. Square root of 4 is 2. 2 to the 5th is 32. So then I would just start adding them together. So what's nice is 4 and 16 make a 10. So they make 20, because 4 and 6, 10. 8 and 32 make a 10, so that makes 40. So 40 plus 20 is 60. 60 divided by 2 is 30. Number 2, go ahead, take a minute, read through that. It says the graph of f is shown above. On the following, which has the least value? So for part A, that would have the most value because that would be the most accurate. So since the graph, well, not necessarily the most accurate, but that would have the most accurate value. Since f is decreasing, if you were to draw in Riemann sums, your lefts would all be above. But if you drew in the rights, they would all be below. So the right Riemann sum is going to be smaller than the left. And again, if you looked at or compared the midpoints, that's going to be in the middle. We know the midpoints are usually pretty close to good. And then we also know trapezoid is going to be the slants of the line. So that's usually really close as well. So like your trapezoids and midpoints are going to be really close, where your right Riemann sum that I have up there in orange is not. So letter C would be correct. All right, number 3. If 3 subdivisions of from -4 to 2 are used, what is the trapezoid approximation for that problem? So this is a non-calculator trapezoidal approximation with 3 subintervals. So that's my A, that's my B. So remember, it's delta x equals B minus A over the number of intervals. So that means that the width of my intervals is 2. It's the trap method. So now trapezoid with equal subintervals. A trapezoid equation is 1/2 height, base 1 plus base 2. So I need to have 3 trapezoids. Base 1 is going to occur once. Base 2 is going to occur twice because it's going to be the height of the beginning and the height of the end. So if you think about 3 trapezoids, I don't even care what the function looks like. Here's trap 1. Here's trap 2. Here's trap 3. They share these bases in here twice. So base 1 is plugging in -4 to that original function, plus 2 times that function, but now we're plugging in the second part, so you add 2 to -4, you get -2, because we're moving its subinterval lengths of 2. So your beginning and your end. We repeat it because it's going to repeat here. The next one's also going to repeat. That would be e to the 0. And then our last one, it stands alone. So that's e to the 2 over 2. So 1/2 times 2 cancels. All these 2's in the middle cancel. So I have e to the -4th over 2. E to the -2, e to the 0, and e squared over 2. So this one's over 2, this one's over 2. And when I look at my answers, none of them have fractions. But if I look in here, these ones have 2's. So what they did was they factored out a 1/2. Which is kind of silly, but they did it, and that put 2's back on my 2 here and took them away from my 2 there. We'll have one similar to this. Oops. I can't hear you, Nick. Hold on. All right, try now.
Hello.
All right, we can hear you now.
I was going to say, shouldn't it be e to the positive fourth? All the ones, the exponential.
Oh, yes, thank you. I wonder why I have negative in there. So, do you see where I put all my negatives here? And the reason only my 4 is goofy looking is because it's the only one that didn't repeat. So the actual problem to start was negative. So I dropped my negative when I plugged them in. So it would become positive. But it's the only one that's an issue because the 2's repeated. So that was positive, that would be negative, that would be positive, and e to the 0 doesn't matter. It also very much so bothers me they don't change e to the 0 to 1. This is also from 1988. So, maybe they'd keep some of these same rules, but I think they've changed a lot of their, they would change the e to the 0 to 1 today. However, I wanted to go over that question because when I looked at some of our free responses on the mock exam in the past, it felt like we lost or forgot how to do our trapezoids or our Riemann sums. So is this helping you remember your formulas? Because it definitely felt like we were forgetting how to do our Riemann sum formulas. Because the one free response that I passed back on Friday, or maybe it's the one I'm passing back today, we definitely did not multiply or do our Riemann sums. You were picking the wrong values. So I wanted to make sure we touched on it. Okay, the function f is continuous on the closed interval to 8 and has the values given in the table above. Use the subintervals 2, 5. So it's picking my rectangles 5, 7, and 7, 8. What is the trapezoid approximation? So again, it's 1/2 base, so that's the distance between these. So that's 3, 2, and 1. So they're changing, so I can't write one set formula. I have to do 3 trapezoids. So it's 1/2 the width, and then base 1 plus base 2. So that's your f of x values. So 10 plus 30 is 40. 40 divided by 2 is 20. 20 times 3 is 60. Half and 2 cancel, so you get 70. 40 and 20 is 60. 60 divided by 2 is 30. 70 and 30 is 100. 160. Okay, and then 5. 5 is going back and remembering that rule. So that is that idea that we can rewrite a summation integral as a integral and an integral as a summation. So you need to know delta x. So So delta x is upper minus lower all over n. So in this case, it's 2 over n. So knowing that it's 2 over n, you can automatically eliminate A and C. So even if you forget the middle part, just knowing how to find delta x, you can eliminate 2 parts. So now we're down to B and D. And the idea is that that 2 gets multiplied by the k inside as well. So we had to have the one that had this inside, but we already eliminated C, which makes my correct answer D. Because it's x to the 4th, so we needed to have the 4th power here, which they all did, so that wasn't helpful.
Ashton Kennedy, please report to the office. Ashton Kennedy.
dx, well remember dx represents the width of the triangle or rectangle, so that's why we replace all of the dx's with that. Okay, jumping over to question 6. We've now jumped topics. This is now area of a curve or curves. This is a calculator question. So go ahead and take out your graphing calculators. It says let R be the region in the first and second coordinates bounded above by the graph y equals 20 over 1x squared. So I'm going to go into my y equals. I'm going to type in my formula. Bounded by that graph as well as the line y equals 2. So I'm going to type 2 in for y2. And then I need to know where they intersect, or at least approximately where they intersect. So that's 2x squared plus 1 equals 20. So algebraically, I can find where they intersect. If I had zoom 6, I would also have been able to see the blue curve as well as the red curve. And I could also do second trace, intersect on there, and find where the 2 graphs intersect using my calculator. Now in this case, it was pretty easy for me to figure that out algebraically, so I just did the algebra, but you could also do it on your calculator. So what we need to do is integrate then from -3 to 3, the top curve, which is y1, minus the bottom curve, which is y2. So it's top minus bottom, or in this case, 20 over 1 plus x squared minus 2. So we're going to just go to our calculator. We're going to get out of the graph. I'm going to go to Math 9, -3 to 3, vars, y vars function y1, minus vars, y vars function y2. Integrating with respect to dx. Alright, great. Okay, so that gives me, the area between my 2 curves, right? So now it says, if the base of a solid whose cross sections, so now I'm changing it to volume, so this is area, if you want to find volume, then you have to take into account the shape. So my shape is a semicircle. So that means this gets a 1/2 pi, and it's the radius squared. Well, the radius is the top to the bottom curve, so we're going to add in our squared. So again, area can be transformed to volume by changing our shape. So now we have volume. So we can take that function we set up. You're going to have to either retype in your y1, y2, or add parentheses so you can square it. So you get 443, but don't forget that answer is a trap, because I have not yet multiplied by my pi halves. And because it's pi halves, but again that is also being cut into semicircles, we have to divide it by 2 one last time and get C. So if you're revolving it around the x-axis, then you're automatically a circle. So if they don't tell you a shape, but they tell you an axis, then it's automatically a circle. So again, area of a circle is pi r squared. They tell you we're in the first quadrant. I need to know where F and G intersect, so I'm going to set them equal. And then square. If I squared it over there, I could get rid of my fractions. So 3 times 1 is 3 times 2 is 6. And again, if you don't want to work with fractions, you can multiply it all through by 4. And then what's nice to see is that this is a square, perfect square, and it is factorable. Nope. It's not. Gross. Yeah, and you see how like my front board cut it off? Like I looked at the screen and not at the whole problem. My bad. Maybe I should read the whole problem. I just looked at the whiteboard. Yeah, so they actually gave me my intersection, which was 9. made that hard. Okay, so top curve is going to be your 2 square roots of x. Bottom curve is going to be x minus 3. We're bounded by the x-axis and the y-axis. So, and we were told our point of intersection. We don't care what's happening over here, even though they never intersect, because it says it is bounded by that line. So that allows me to create my interval from 0 to 9. We just said top is 2 square roots of x. Bottom is x minus 3. The values are squared. And there's my pi. Okay? So another idea where we're using our Riemann sum. So you have to know that the bounds represent this height at the end. So my dx is equal to my b minus a all over n. So I need my dx to be represented by 2 over n, which means I can eliminate multiple choice C. And on the inside, I'm also looking for that 2 over n to be multiplied by my k. So I'm also looking for a 2kn. In letter B, this 2n's inside instead of outside. So that's incorrect because it would only multiply it by the 2kn, not the 1. So you can eliminate B. And then letter D, the difference from D to A is the 1 on the inside. And again, it's initial plus that change. So it's going to be A because my initial or my starting point is 1. So we need to represent that 1 within the summation. And then this is a calculator allowed free response, which I feel like we didn't do in area or volume with a calculator. So this was from the 2014 exam. So what we're going to do is go to our graphic calculator, put in our functions, so delete the other functions. So it's enclosed by our graph and that horizontal line. So I'm just going to put that line in as well. find the volume of the solid rotated about the line y equals -2. So we're actually going to skip A because that is your washer method. So this year they're going to be nice. They're only ever going to rotate it around the X or Y axis. So we're going to jump down and look at an isosceles triangle because we didn't look at any of those when I assessed you on your test. So region R is the base of a solid. For this solid, each cross section perpendicular to the x-axis is an isosceles right triangle. So that means this is like the base of your triangle, and then there's your heights, and the sides are always going to be the same. An isosceles right triangle is a 45, 45, 90. So what that means is that in order to be able to find our distance, we're going to go from the top to the bottom. So it's 1/2 base times height. And again, the leg is in my R. So we have to find a leg. And the nice thing is it's a right triangle. So here's your 4. Here's your curve. So the length of the curve is always going to be the 4 minus the function. And that's going to represent the leg. But if you think about the fact that this is a right triangle, the leg and the height are the same because it's an isosceles. So like leg and height are the same because it's isosceles. So we have our 4 minus f of x, and it's going to be squared or multiplied twice. Base and height are the same. How do I know my bounds? Well, I need to know where the graphs intersect. So I'm going to go to the calculator. I'm going to hit Zoom 6. We're going to go to second trace, go to intersect. And start with the left side. We see that one's really nice. They intersect at 0, 4. So my lower bound is 0. We're going to go to intersect. And over here we see that they intersect at 2.3. So 2.3 is my upper bound. So it's a calculator question. So I'm going to hit second quit, math 9, 0, 2.3, parenthesis, 4 minus bars, y bars, function y1, close parentheses, squared, and dx. Now, there's a 1/2. I could have typed that 1/2 in front of my integral, or I can divide by 2 at the end. So you can actually type in the 1/2 in front. and you'll see you get the same answer. The vertical line x equals k divides R into two regions with equal areas. Write, but do not solve, an equation involving integral expressions whose solution give the value of k. So, if they give the value of k, that's the point at which one side is going to be equal to the other. So we know that the volumes have to be equal, or the areas rather have to be equal when you integrate from 0 to k and k to 2.3. We just don't know where k is going to be at. Any one of these lines could be k. It can't just take 2.3 and divide it by half because the curve isn't symmetric. So we need the integral from 0 to k of 4 minus f of x dx to equal the integral from k to 2.3 of 4 minus f of x dx. They don't tell you to solve because finding that k value would be very, very, very difficult. Okay. So yesterday we did have a quizzes. I want to just go over the most frequently missed question from that, and then we always end with an FRQ. So I just want to go over the most missed question, and then we will be good. So overall, the highest missed question, which there weren't many, our lowest percent rate was 50. So that was pretty good. But question 18, which may not have been 18 for all of you, we had a 50% rate here. So we were split pretty evenly. And again, the idea is that we forgot you have to multiply by the derivative of 2x. So that's why this one here, or you had subtraction, I'm not sure. I don't know why we had subtraction, but it's this plugged in with 2x, so e to the 2x times derivative of 2x, which is 2. So that's where you got 12 e to the 2x. Okay, we did pretty good on our formulas. This is the only other one we were split pretty evenly. So again, the tangent line formula is y minus y1. y1 is technically f of x1, not f of y1. And then fundamental theorem of calc. Fundamental theorem of calc says that you integrate and derive and they cancel each other. You can integrate and derive and they cancel each other. This is a non-calculator for your response. that means is do not try to do crazy, like leave your answers as fractions. Also gives you a hint that there is a fraction. You want to do it on notebook paper and not on here, that's fine. You want to flip back and forth and write on the back, that's fine. Okay, so what I'm going to do is give you extra time. You can have till the bell rings. Okay, if you're done, you can turn it in back there. There's a link for a couple multiple choice questions for you to review and quizzes that are on Riemann Sum and volume. I would suggest having paper out when you work on them. That game code link was sent on, well, I'm going to send it on Teams now. So if you're done, you can put it on the table. If you're not done, you have till the bell rings. Perfect. Thank you. Thank you, Nick. Printers now.